Hi, welcome to Getting Started with Data Wrangler in Microsoft Fabric. I'm Brian Hittney, Solution Architect focused on data and analytics. So Data Wrangler is often used in data science scenarios because of how it can help with feature engineering and exploratory data analysis. But it can also be really useful in helping to do data orchestration in our ETL pipelines. And in this video, we're going to look at how we could do that. In this case, what we have is a event stream that's writing our data into a lakehouse, and it's also writing it into a KQL database for real-time reporting. So as the data comes into our lakehouse, you can see that we've got our symbol, which is a stock symbol, our price, and a timestamp. And if we look at the data in the lakehouse, we could see that we're putting that data in our raw stock data table. We could see all of that data that's coming in. So in this case, we have 8 different stock symbols, but this could potentially be thousands, or it could be thousands of different sensors writing that data in. So what we often need to do is cleanse that data and then aggregate it somehow that we can then use later on when we're building additional models or taking it into our ML workflow. So that's what we'd like to do. And so in order to do that, I've got a notebook that's going to help us out. And all of this code is available for download, so you can check this out. I've got the link in the description where you can download all of the code and try it out. So here in the Lakehouse 2 notebook, what the purpose of this notebook is to help build our medallion architecture. So it's going to take our raw stock data and then cleanse and aggregate, group by all of the different fields that we care about, and basically aggregate that data to the minute and hour level to make it easier to work with later on. So let's go through how we're going to do that. And I also want to point out that traditionally we would break this up into different lake houses. In this case, I'm going to keep everything here in the same lake house just for ease of demonstration. So let's start off. I'm just going to kick off this notebook. We're going to run through it one cell at a time just to see the workflow and how we're going to do this. So the notebook is going to expect the data in our raw stock data table. So you can see that we've got that set up here. So if you're doing this yourself and you happen to call the table something else, then you could just rename it here. And then we've got a couple of methods that are just going to create our aggregation tables. So we've got those here, and obviously if the tables already exist, it's not going to overwrite them. But we're going to create two. We're going to create a table that stores the data at the 1 minute level and then also at the hour level. So that way, if we refresh our tables, you can see that the minute is already there, and now we should see the hour. So these tables now are going to store then our symbol and the price for that 1 minute or 1 hour interval as that data comes in. So obviously these tables are now empty, so we're just going to go through this and then clean up some of the data and then aggregate it using Data Wrangler. Now the first step that we're going to do is do something that I'm creating here, a special data frame. I'm just calling it the anomaly data frame. The point of the anomaly data frame is to create a few rows that we can easily visualize and see, so that when we're cleansing our data, we could see exactly that what rows we're filtering and if our cleansing is working as intended. This is especially useful if your data that's coming in is fairly pristine and almost never has any outliers that you need to deal with. It's good to create something like this so we can test and verify that any kind of cleansing that we'd like to do. So you can see that we have a null value here for a symbol. We have a couple prices that are either null or invalid, at least by our criteria. Anything with a 0 or less price is going to be considered invalid. So again, we'll create this data frame here to support our testing. And then we've got a couple of methods here that will do merge statements to write this data into these aggregation tables. So pretty typical syntax here. This will allow us to update any data that already exists in the table if we'd like to support that. Otherwise, we could just do a raw insert if we're only going to be doing that. So we've got these here. We're going to call these later on after we do our aggregation. So we have the merge hour and the merge minute. So the first thing we're going to do is we're going to see what is our latest date that we currently have in the minute aggregation table, which is, there's nothing in the table, we just created it. So we're going to give it a default value of some previous date, in this case, just January 1 of 2000. So that'll be our cutoff date. Otherwise, as we run this, then we'll look at what the most recent row is in that table and then use that as the cutoff date so we know not to ingest any previous data. Then what we're going to do is go after our raw table where everything is after that cutoff date time. So in this case, we're going to grab everything that's in that table. It should be pretty small. We put a limit here of 5 million rows. This is just arbitrary for testing. If you want to do data chunking and try this out over a set, you could put this to whatever you'd like to. Practically, though, because of the size of our data, we could be loading years of data here without any concerns of memory or anything else because this data set is pretty small. So now we have our data frame loaded, right? That's DF stocks. It has all of our data, the symbol, the price, and the timestamp. So there's a few things we want to do. The first thing we're going to do is look at how we might clean this data. So I'm going to put my cursor here so we're in this cell. This is our placeholder cell. And then if I click on the data tab at the top, there's transform data in Data Wrangler. And if I open that up, you'll see that we support Pandas data frames, and then also, this is somewhat new, is the Spark data frames. And this is where it really is useful for our ETL pipelines, because usually we'll use Pandas when we're doing a lot of data science, but when it comes to ETL, we're often using Spark data frames. You can see that we support both of those. Now, the other thing we could do is choose the sample that we'd like to take. In this case, it's going to pick the first 5,000 rows. There are cases where we might want to grab 1,000 rows or 5,000, something of a random nature, or maybe grab the last 5,000 rows. We're going to look at an example as to why you might want to do that later on. And a situation where choosing the sample could help you out if you're having trouble having Data Wrangler do some of the column selection and filtering that we'd like to do. So again, we'll see an example of that in just a minute. So we're going to use the anomaly data frame that I just created for this example. So you can see that we have DF stocks, we have that watermark that I created earlier. I'm going to select the anomaly data frame, and Data Wrangler is going to load. What we're going to see when it loads is in this center pane here, we're going to see a grid of all of the data that is in our data frame. And over on the left, we have operations. This is where we could select the different operations we would like to carry out for cleansing or aggregating or doing things like one-hot encode for our data science. So different feature engineering things that we could do. So right away, you can see that it comes in. It's got the index, which is just the row number, and then our symbol, price, and timestamp, and again, visual indicators that show us all about our data. We could also see that there's some missing values in here. So specifically, we have one row number 2, that is missing our stock symbol, and then a couple of prices are missing as well. So in order to do this, we're going to filter out these missing values, and then we're also going to filter out any 0 or less than 0 values as our cleansing routine. And what we're going to look to do is create a number of cleansing steps. And what's going to happen is every time we create a new step, Data Wrangler is going to transform that step into code that then will be put back into our notebook that we can then modify if we would like to. So first thing we're going to do is go to find and replace, and we're going to drop missing values. So we'll see that option is right here, drop missing values. And it's going to ask us to select a target column or more. So we'll select the symbol and price columns, and then we'll click apply. And you'll see that while it's loading here, it's identified 2, 7, and 8 as having missing values in the symbol and the price columns. So those are going to be deleted then from our data set. So if that looks good, we'll click apply. And you'll see that the resulting data set is now going to be absent of those columns. So that's good. That's the first step. That seemed to work as intended. The next thing we'd like to do is drop any invalid prices. So again, for us, it's 0 or less than 0 are considered invalid. So to do that, what we'll do is under sort and filter, I'll click filter, and it's going to ask us to select a target column. We'll select price, and then a condition. We'll say condition is less than or equal to 0. Now, the default here is to keep the matching rows. So when this is run like this, you can see that it's going to try to keep only items with a price less than 0. We want to do the opposite. We want to get rid of everything that has a value, a price that's less than 0 or equal to 0. So we'll unselect the keep matching row. So uncheck that. And now you'll see that it'll flip this to where rows 5 and 6 are going to get dropped. So that's exactly what we want to do. We'll click OK, and we'll be left with only these 4 rows that remain. So this is our basic cleansing operation. I like this. This seems to work. So we're going to click Add Code to Notebook. And it's going to ask us if we'd like to include the pandas code. In this case, no, because we're not doing anything with pandas. We're all PySpark here. And we'll click Add. And we'll scroll back down here. You can see that this is the code that it put in for us. And what it does is it creates a method, in this case, a function that's just called clean data. And it's going to take our anomaly data frame, because that's what we selected. And we can see each step that we told Data Wrangler to do is called out here in the function. So we can see the first one is drop rows with missing data in the column symbol and price. And then finally, filter rows based on price. And so at any time, we can come in here and change this if we'd like to. We could change it manually. We can remove them if we'd like to. So this is the nice thing, because it's a template that basically helps us build the code that then we can modify if we need to. The other thing we could do is, because I was using the anomaly data frame here, remember that was just for our testing. And what we want to do now is apply this to our DF stocks that we had earlier that was loaded from our data frame. Remember, this is right here where we load DF stocks, has all of the real values that we care about. So that's what we would like to do. So instead here, we're going to change this to DF stocks. And as long as the schema matches, then we can pass in any data frame that we would like into our clean data routine. We can keep this one as anomaly data frame. That's fine. It's just the name of the local data frame here that will be used in clean data. If we'd like to clean this up and rename it, obviously we can do that. There's no problem there. And then finally, what I'm going to do, instead of calling this anomaly df clean, I'm going to change it to df stocks clean. And then we're going to display df stocks clean like this. So if we run this routine now, we'll see that the output of our cleansing routine will have df stocks that's been cleansed. But in this case, it probably is identical to the data frame that we first loaded, because the symbols, the price, and the timestamps, I'm guessing, are clean that are coming in. So it could very well be that this is identical, and that's fine. We've tested it on our anomaly, and we're pretty sure that it works just fine. So now that we've got this done, we have our basic cleansing in the form of df stocks clean. Now let's move on to a little bit more of an advanced scenario. Now what we would like to do is do some engineering on this data, create a date stamp that is based off the timestamp, and then do a few different aggregations to get that data down to the hour and minute level, and then summarize the price over that time period. So let's load Data Wrangler again, and you'll see that this time we'll take our df stocks clean data frame and load this up. We'll give this a moment to load. And you can see that we have the symbol, the price, and the timestamp. And the first thing we're going to do is we would like to get a date component out of our timestamp column here. So the timestamp has both the date and the time. We only want just the date, because that's what we're going to store in the table. So in order to do that, we can click on New Column by Example under the Operations tab. And it's going to ask us for a target column. So we'll select the timestamp, and then the name of our new derived column, which we're going to just call a date stamp. Okay. And we're not going to click apply just yet. You can see that it's going to wait for us. If we click in here, it's going to say enter an example. And this is powered by Microsoft Flash Fill, which if you've ever used this in Excel, it's a pretty handy way to provide an example. And it's going to match our example against our target, which is the timestamp column, in order to derive what it is we're looking for. So this is really helpful in these kinds of situations where we can easily type in what it is we're looking for. I could say, for example, I'm looking for 2024-0206 based off of this timestamp. And if I hit enter, it's going to look at this and it's going to try to pattern match and see exactly what I'm looking for based on the timestamp. And if it works correctly, you'll see that it will fill out all of the other fields here with that pattern. And we can look at the code as well and see what is proposing as code. And you can see that, okay, with our input of this timestamp, the output will be 2024-0206, and you can see that it's doing a string from time in this format. So that works pretty well in converting this into a date. The only potential negative here is we're looking to actually convert this to a date, which we'll talk about a little bit later on, the challenge here. Right now it's a string, which will be okay because we can do an implicit cast on this later. But there's a little bit of a limitation here in how easy it is to work with. What we could do is we could use a toDate on it in PySpark. We can use the toDate function if we'd like to. So this is one of those examples where if a function that we know exists does not exist inside Data Wrangler, we could always do it manually afterwards. So we'll take a look at that later. The challenge here is that Data Wrangler needs to support Python, it needs to support Pandas, and sometimes types are handled differently in one versus the other. So decimals are a great example. They're just handled completely differently. So it's very hard to make something generic work across all platforms. So we have our date stamp, and so that's pretty good. The next thing we want to do, I'll click apply there. And in addition to our date, we also want the hour and the minute columns. So we're going to say a new column by example. We're going to do almost the same thing. We're going to create a new column called timestamp, and this is going to be called the hour. And it's going to look for an example here. Again, we're going to do the same thing where it powered by flash fill. We're going to give it the hour component. And so if we look at the timestamp, we could see that the hour component is 6 p.m. or 1800 hours. So I'll just enter 18 and hit enter. Now, if we're lucky, that's all we have to do, in that it should hopefully figure out that what we're looking for is the hour component of the timestamp. And if we look at the code that it provided down below, we could see that this function is in fact returning the timestamp.hour. So it got it. And the reason why it might not is if our hour is currently, for example, 00 because it's midnight and the time is 00 minutes, sometimes it's not clear exactly what we're looking for. And in order to help it figure it out, we can enter rows on other columns or other rows as well. We can say, okay, maybe this other row is 1900 hours or 20, whatever we'd like to put in there. And that should help it figure out that we're going after a certain column. So if it's ambiguous with just one, you can enter a value on multiple rows. This is the case I was referring to earlier, where it can be helpful to select a random sampling of rows if you're having a trouble using something like flash fill to help parse a hour or minute. Consider using that random sample in order to give more distinct values in order to pick from. But this is good. This I can confirm here that it's got the hour. So I'm going to click apply. We're also now going to do the same thing to extract the minute. So we'll do another new column based on the timestamp, and we'll call this minute. And here we're going to enter then an example where the minute in this case is just 01, and we'll hit enter. And we'll see if we're able to extract the minute from the date. So flash fill runs, and you can see in this case it actually got it wrong. It is looking for timestamp.year and it's converting it to a date time. That's not exactly what we're looking for. So what we can do is we can then scroll down and try to find then another minute, like right here, and enter 2. And it's going to run, and hopefully this time what will happen is it will come back and it will see the other row that we put in, and now it's got it. Now it says, like, now I get what you're trying to do. You're trying to get the minute, and we have the minute value. So I'm good with that. We're going to click apply. And so now we have the hour and the minute. So that's great. The other thing we want to do though is these are just text right now, and I would really prefer to have those as integers. So couple ways we could do that. We could use it in operations, but it can also be done here in the corner of each column. For example, hour, we'll double click the ellipsis up there and we'll say change column type, and target column is hour. And instead of just object, I'm going to change this to int32. Int32 is a little bit of an overkill for such a small number, but it's standard integer size, so that'll work for me. We'll click OK. And I'm going to do the same thing for the minute. We're going to come up here, change column type, and change this to an int32. Click apply. Okay, so let's review. We've taken our timestamp, we've gotten our date out of it, we've also then derived an hour and a minute, and now we've also converted that into an integer. Now comes the part where we're going to do the group by and the aggregation. So if you've done this a lot in SQL, you get it. You know how to do a group by the columns that you care about, and then you aggregate the rest of them. In this case, what we'd like to do is aggregate the symbol, the date, hour, and minute, and then aggregate the price. So in order to do that, under operations, there is group by and aggregate. And you're going to see that it's asking us which columns do we want to group by. And we're going to select the date, hour, and minute because we want to fold everything down to that level. And then we're also going to select symbol because we want each symbol to have its own row for each date, hour, minute combination. So we'll select that. And then we're going to add 3 aggregations. And all of these aggregations are going to be based off of the price. So I'll select price here, and price here. And what we'd like to do is over this 1 minute time period, because we're getting data coming in about every second, we'd like to aggregate now the price by knowing what the minimum price is, what the maximum price is, and then finally what the last price is during that 1 minute period. So it wouldn't matter if we got 5 readings over that 1 minute, or if we got 5 million. We'd like to collapse this data down to know what the minimum was over that 1 minute period, what the maximum was, and then finally really what the last value or the final price was. So that's kind of the benchmark, right? It doesn't really matter if the price was super low during that 1 minute or super high. It might be for some reports, so we know how high it went or how low it went. But the most important thing really is what was the final price at the end of that 1 minute time period. So that's why we're doing all 3 of these aggregations, and then we'll click apply. So we now are going to group all of that data, and we have everything aggregated the way we would like it to. And so we're going to add this code to our notebook. We, again, here don't need the pandas code, and we'll click add. And you can see that this code generated by Wrangler, you can see this one is quite a bit longer. There's a whole lot going on here compared to our first one, but the principle still applies. If every step that we took, right, where this first one was derive date stamp from timestamp, where it just writes a user-defined function that returns the time as a certain format. So we can come in here and change this at any point. If we would like to just call the PySpark.sql.toDate on the timestamp, have at it, right? We can come in here and do that. This is the code that Data Wrangler did for us. Similar here where it wrote this routine to do the hour conversion where it just returns timestamp.hour in a string in the format like this, where there's 2 characters in the string. Again, we could simplify this if we'd like to, and then instead of returning it as a string type, go directly to an integer type. We could do that if we'd like to, right? That's the great part about this, is that it's a template for us to use. And you can see that it also called this clean data. That's going to be the name of the function no matter what every time we do this. So we're going to do a few things here. We could keep this the same, even though the previous function was called clean data. I like to call them something unique, so that way it's clear what it is we're doing. So I might change the name of this function to like aggregate by minute. Again, that way it's a little bit more clear in the future what is going on. And then instead of calling clean data, we're going to be calling aggregate by minute. And it is taking dfstocks clean, which is good, which is what we want it to do. In this case, though, we'd like the output, instead of just calling it dfstocks clean _1, I'll change this to dfstocks ag minute for our aggregation of the minute values, and then we'll display that like so. And so now we've got a different data frame that's going to be the output of all of this. So let's run this, and we're going to see actually that it's going to generate an error. And you can see that it did that. And the reason why is there's a little bit of a bug. Hopefully by the time you're watching this, it won't be there anymore, but I can't guarantee that. You can see that for some reason my PySpark function here, it's getting labeled as f.f when it's looking at the column timestamp. And so our PySpark functions, this is the alias we gave it, is f. You can see that here on line 4. I don't know why it's doing that twice. It should only be just once. So it should just be, instead of f.f call, it should just be f.call. So why that is, I don't know, but that happens in a couple of spots. So it happens there, and it's also happening here. So we'll remove that manually. And so if you see that same error, well, hopefully this will be getting fixed really soon. So with that done, let me rerun this now, and we should see the output be a simplified view of our df stocks. You can see that we have the date stamp, the hour, and the minute, and then the symbol, the min price over that minute, the max price, and then the last price over that 1 minute time period. So this is exactly what we wanted to do. And you can see that in the minute table here, we haven't written the data yet to the table, but that's what we're looking for. We're looking to aggregate everything down to the 1 minute. So instead of having roughly 60 values for the because stock here, we've taken it down to just 1. So that looks good. And we'll call the merge minute ag function here, which will take that and now write it into that table. So once this is done, that table will be populated with everything that's here in the data frame. So that was successful. And now the next thing we'd like to do is do that same thing, but instead of aggregating per minute, we'd like to aggregate at the hour level. So let's go to transform Data Wrangler, data frame and Data Wrangler again. And this time we're going to select the dfstocks ag minute data frame. And this will be a little bit easier because really what we're looking to do is fold the data down to just the hour level. So you can see that we have everything here at the hour and minute level. So I'm going to go down to group by and aggregate, and we're going to select the columns. We're looking to aggregate by the date stamp, or group by rather the date stamp, the hour, and the symbol, right? So we're essentially going to be dropping the minute here. And we're going to then add, similar to before, 3 aggregations where we'd like to look at the min, max, and last price. This is a little bit tricky, and the reason why is we're aggregating data that has already been aggregated. So we just have to kind of keep that clear in our head as to what's going on. And what we want to do is essentially, of all of the minimum prices for that hour, give us the minimum. So the minimum of the minimum, and same thing, give us the maximum price of all the maximums within that hour, and then finally the last price. So that way we'll always have a true reflection of what the minimum was over the course of that entire hour, what the maximum was over the course of the hour, and then finally the last price over the course of that hour as well. And then we're going to click apply. We'll add this code to our notebook. Scroll down, and code is right here. In this case, instead of it being called df stocks ag minute clean, we're just going to call this df stocks ag hour. And we'll look at the display here. There's one other thing we're going to do that we're going to change, and that is if we look at the way it is aliasing these tables, you could see that it is calling the price min, min. And that's, again, an artifact of the fact that we're minimizing an already minimized column. So this looks a little confusing to call it price min, min and price max, max. So in order to keep the column names the same, I'm just going to rename these. So it's price min and it is price max. And then finally, instead of price last, we're just going to call this price last, like so. Okay, and then we're going to run this. And you'll see now that we've taken the data that was aggregated at the minute level, and now we have it crunched down all the way to the hour level. And because we just started ingesting this table when I started the recording, we only have data for this 1 hour. So we've reduced the data again, and our column price min, price max, price last, that's exactly what we're looking for. So we'll write this now into our hour aggregation table. And then finally, we have a couple of SQL commands here that we'll run. Just in order to select the data, we can kind of get a visual to make sure that everything looks correct. We're getting the data out of the minute aggregation table first. We could see the min and max dates that are there, and then all of the data per minute. And same thing here with our hour aggregation, that looks correct. So that's an example of how we can use the Data Wrangler in order to help us with our ETL pipelines. The great thing about it, and the key takeaway here, is by having all of this code here as an example for us to work through, we can take this and edit it at any time. If we know a better way, like if I mentioned before, if we just want to call toDate from the PySpark SQL function in order to get a date component out of it, we could do that. So we can simplify this however we'd like to. But out of the box, this is really a helpful way to help us do some transformations on our data and support us in our orchestration of building, in this case, aggregation tables that we'll then use inside some of our data science routines, and then also building our data model a little bit later on. So that's an example of using Data Wrangler. Hope it was useful, and see you next time.